Hey friends, this is Eric White with OpenXmlDeveloper.org. Today I'm really happy to introduce a new class in PowerTools for OpenXML, and that's the class of OpenXmlRegex, which enables you to search and replace content in word processing ML and presentation ML. This little class has a number of key features. First of all, you can search for content via regular expressions. Second of all, you can replace that content with new content after you've found particular content. You can, of course, delete content by replacing content with the string.empty. The next two features are pretty interesting. It works if the existing document contains revision tracking, and optionally, it will replace content with revision tracking markup. It mimics Word's behavior with these two features. And last, you can use a callback to accept or reject individual replacements. In the screencast, I'm going to demonstrate the OpenXmlRegex class. I'll talk about some of the more interesting semantics of this class. In the screencast following this one, I'm going to walk through the code and show you how the code works. It's kind of interesting. It looks like it's complicated from the following demo of the OpenXmlRegex class, but the code doesn't turn out to be that awfully bad. Of course, PowerTools for OpenXML serves two purposes. First of all, you may actually need to use this OpenXmlRegex class and replace some content in a word processing document or a presentation document. It also serves to show how to do these types of operations. I fully expect that these classes will get translated to other languages such as Java and C++ and JavaScript and so on in the future. So let's get started. Here I have the zip file for OpenXML PowerTools Core version 2.7.04. You can find this download in the Downloads tab on Codeplex at powertools.codeplex.com. I'm going to start with this and unzip it and build the example and walk through it right from scratch. So I'll right-click, extract. I always get rid of that extraneous directory. I'll go into the OpenXML PowerTools examples directory, and I'll open the OpenXML PowerTools examples solution. First thing to do here is I am going to rebuild the entire solution. And there it completes. I have an example here, OpenXmlRegex 01, that shows a lot of the different use cases for using this particular class. First thing I'm going to do is I'm going to go into OpenXmlRegex.cs and show you some interesting aspects of this API. Here is the match method. And what you do is you pass in an IEnumerable of X element for your content to search. So this means that if you want to, you can select a number of paragraphs, any specific paragraphs in your OpenXML document, and pass those into this match method. You can also then pass in the regex that is the second argument to the match method. A little more elaborate form of the match method is one where you can pass in a callback, this found callback, and it'll get called for you for each and every time that it finds the particular regex in the content that you pass to match. Now let's look at this replace method. With the replace method, again, you pass in the IEnumerable of X element of content that you want to search and replace in. You pass in the regex that is going to be used to match whatever content you want to match. Next, you pass in the replacement string. If you pass in the empty string for a replacement string, it effectively just deletes the content that it finds. Finally, you can pass in a callback, and with this callback you can return true or false depending on whether you want to do the actual replacement for each match. One more overload of the replace method is interesting here. Again, you pass in IEnumerable of X element, you pass in your regular expression, you pass in the replacement string. Here's a callback that enables you to do replacement or not. By the way, if you just pass in null for that callback, then it just takes that as true. If you just want to do the replacement without examining each replacement, then pass in null for that callback method. Then you pass in true for track revision, and you pass in a string that contains the author name, and that will become the actual author of each revision that it makes. The OpenXmlRegex 01 example starts with this test document right here. Let's go in and look at this test document. We're going to be looking at this test document one paragraph at a time using various methods of the OpenXmlRegex class on it. So we can see that this first paragraph contains the text, "Video provides a powerful way to help you prove your point." Let's go look at the first example in OpenXmlRegex 01. I'm going to do something here. I'm going to if false all of these other examples so that we can look at the functionality of each one of these examples in isolation. This first one simply looks for the regex of the text video, and it's going to tell us how many matches it found. Let's Control F5 this, and sure enough, it found one instance of that particular regular expression. When you need to do case-insensitive search and replacement, what you do is you create a regex passing in regex options to the constructor of the regex, and that enables you to specify that you want to ignore case when you're matching content. So in this particular case, it's going to look for this word video with a lowercase v here, and it's still going to find one instance of that particular text, and sure enough it does. The next example shows how to use a callback when you are matching content, and in this particular case the callback does nothing other than print out the actual text that was matched. One of the arguments to this callback, in other words one of the arguments to this lambda expression right here, is a match, and this is the match class that is part of the system.text.regularExpressions namespace. So there are lots of things that we can look at in that match object. We can find out what character the match started at, how long the match is, and so on. And one of those fields in that match object is the value that was matched. So in this particular case, we're matching for lowercase video, and we're telling it that we want to ignore case, and then we're printing out the value, and the value that it's going to print out is the word video with the uppercase V. And that's exactly what we see. Well, that's enough about matching. That's certainly easy. Let's go on to some of the more interesting stuff about replacing. One thing that you're going to see here is the way that this example determines content is it takes the X document for the main document part, it uses the descendants axis to get a list of all the paragraphs, and then it skips the first one and then takes one. So this particular replacement is only going to operate on the second paragraph down. is going to leave all other paragraphs in this document exactly as they were. And the regular expression here consists of the caret character, in other words, shift 6 character, and video provides. And so it's going to replace that content with audio gives. So let's run this example, Control F5, and it tells us that it did replace one instance of that regex that it looked for in the document. And now let's go look at the resulting document. Here is the document that it actually generated, and we can see here that it actually replaced it with audio gives, a powerful way to help you prove your point. And we did it only in the second paragraph in the document, as I mentioned. The next two examples are pretty simple variations of that particular theme. This one looks for the word powerful and replaces it with the word good, and that's only going to happen in the third paragraph. And in the next one, it's going to look for any word preceded by a space containing A through Z and a decimal point, i.e. a period. Also finally match it to the end of the line. And it's going to replace that content with super good point. So we're going to see 5 and 6 are both going to replace one instance of the content that it finds. And sure enough, it does. And let's look at the resulting document here. 5, we can see it does in fact now contain the text video provides a good way to help you prove your point, and video provides a powerful way to help you prove your super good point. Examples 7, 8, and 9 delete content. So 7 looks for video provides at the beginning of a paragraph and then replaces that with string.empty, or in this particular case just with quote quote. 8 finds the word powerful and deletes it, and 9 deletes the final period on the paragraph. Each one of these will return a count of 1, and we can see in fact 7, 8, and 9 indicate that it deleted one instance of the regular expression. Examples number 10 and 11 are interesting. What these do is they replace and delete content in text that is already inserted. It does it with the same author, i.e. Eric White, that the original revisions were done with. So let's go back and look at the source document. Here's the paragraph. You can see that this text was inserted by Eric White, and we're going to replace video with audio in the text that was inserted by Eric White. And in number 11, we're going to delete the word powerful, and the original author of the inserted text is Eric White, and the author of the change is Eric White. So what you're going to see here is that video is going to be replaced with audio, and there won't be any indication that text was deleted. It takes the point of view that if I was the one who initially inserted video provides, and then subsequently I replaced video with audio, Word doesn't need to track that. It's not tracking every single revision that I make to my own revisions. It only provides the next reader of the document with the sum total of all of the revisions that I've made. So we're going to see in this paragraph, video is going to be replaced with audio, and in the next paragraph, powerful will be deleted. We won't see an indication that text was deleted. Control F5 that. It runs and tells us that there was one instance each of replacement and deletion. And sure enough, in this paragraph, we can just see that this text now shows Eric White inserted audio provides. And in this one, it shows that Eric White inserted a way. The next two examples, examples 12 and 13, are interesting. Example 12 replaces video provides with audio gives in content that has been already partially inserted. So let's look at the source document. So content already that has been inserted is this, provides a powerful, and we're going to replace video provides with audio gives. So what we're going to see is that audio gives will be inserted, video will be deleted, and provides will just go into outer space because it was inserted by me and then deleted by me, so therefore that is not a revision that we want to track. And in the next example, we're going to replace to help you prove your point with nothing. And what we're going to see here is that when we replace text with nothing, in other words, when we delete this content that was already inserted by me, that's just going to disappear. And to help you will be marked as deleted. We run it and it shows the resulting counts, which are correct. And when we look at the modified document, what we see is audio gives is inserted, video is deleted because it was in the document and it was in the document without revision tracking, and then we have a powerful as inserted, and that was inserted in the previous markup, so therefore it is still inserted in this markup. And we see what we expect to see in the next paragraph, where all we have is to help you is deleted, and the rest of it just went away because it had been inserted by me and then deleted by me. The next four examples now show the complications that come into play when the author is a different one than the one that already made the revisions. Let's look at the code. This code replaces content in inserted text with a different author. So it's going to look for video and replace it with audio, and the new author is John Doe. Let's Control F5 the example and look at the modified document. And now what we can see is John Doe deleted video, John Doe inserted audio, and Eric White had inserted video provides. And this is the exact behavior that Word would do if you have two separate authors making changes to the same document in the same content. And of course, if we actually go here and we accept this change, we see audio provides a powerful way to help you prove your point, and that's the content that we expected to see after all of revisions have been accepted. So that's replacing content in inserted text. And the next one shows deleting content in inserted text with a different author. So what this does is it looks for the word powerful and deletes it with the author of John Doe. If we look at the original document, in this paragraph, we see that the words "a powerful way" were inserted by Eric White, and powerful is going to be deleted by John Doe. Control F5. And here we can see Eric White inserted "a powerful way" and John Doe deleted powerful. And this is the exact behavior that Word has in this scenario. Examples 16 and 17 are variations on the above examples. The first one is going to replace content that is partially in inserted text and the author is a different author than the original author. Let's look at that one. So the content currently is video provides a powerful way to help you prove your point, and we're going to replace video provides with audio gives by John Doe. And the final example, we're going to delete the content to help you prove your point. John Doe is going to do that deletion. Prove your point was inserted by Eric White. Control F5. And what we can see here is initially Eric White inserted provides a powerful. Then John Doe deleted video provides. And then John Doe inserted audio gives. And when we get down to the final example, we see that John Doe deleted to help you prove your point, and we can't actually get to the content that was inserted by Eric White underneath there in that fashion. But if I go over to the Review tab and I click Next and Next, it'll actually show me the various revisions that were made in that document. There actually are 2 revisions at that point. Key point about all of this is, first of all, it does the right thing. The rules are a little bit complicated, but when you finally get down to it in the markup manipulation, it does the right thing. That's all I'm going to cover in this screencast. In the next screencast, I am going to walk through the code and show you how this code works. That screencast is interesting in that it shows how we can take those fairly complicated semantics that we want to implement and implement them using a pretty simple algorithm. Thanks for watching. See you next time.